In the name of God. Hello, dear students. My name is Masoud. Welcome to Ferkhwa's website. We are going to explain, we are going to solve some problems or some questions have to do with centripetal acceleration, because in previous lessons we explained centripetal acceleration, we proved the direction of centripetal acceleration, and we got a lot of information about the centripetal acceleration mathematically and physically. Right, I'm gonna I'm gonna solve some problem and question for you. We wanna start from the first question, and which is a question of national exam. The question says the time rate of the variation of the direction of velocity. Time rate of the variation. Variation means change. Variation of the direction of velocity, right? Variation of the direction of velocity means, let's say, when the object moves on a circular track. So which one? This equation is the equation, this definition is dedicated for which option? Is it angular speed? Is this definition for angular acceleration? Is it, dedicated for tangential acceleration or centripetal acceleration? Of course, I'm sure you know the answer, because the only type of acceleration that is created by the variation of direction of velocity is centripetal acceleration, right? Not angular acceleration, neither angular acceleration nor tangential acceleration. Only centripetal acceleration is, created by means of variation of direction of velocity. Question number 2, acceleration can be produced by a change in the, gap. We have a gap of the velocity. So acceleration can be produced by what? By the change of what? Fill the gap for me. Is it, of course, acceleration in general, right? Generally, acceleration can be produced by change in the magnitude of velocity, right? Magnitude of velocity, change in direction of velocity, or magnitude and direction of velocity, or none. Of course, C is true, because some type of acceleration actually are created by what? Some types of acceleration are created by change in magnitude, like what? Like tangential acceleration, angular acceleration. But the only type of acceleration that is created by the change in direction of velocity is centripetal acceleration. So both of magnitude and direction, can be true for filling this gap. Question number 3, the SI unit of centripetal acceleration AC is, I told you, centripetal acceleration, like, tangential acceleration is a linear acceleration. That's why any linear acceleration is measured in meter per second square, not rad per second square. And it says A and B are true. No, rad per second, it's not the unit of acceleration at all. This is the unit of, angular speed, omega. That's why only B is true. Let's move on to question number 4, right? Question number 4. Let me read it for you. I'm going to read the question number 4 for you. The acceleration due to the change. I want you to, be careful about this, these questions. If you are very accurate student, if you are, careful student, you can answer these questions, because they are very, accurate. They are very accurate. So accurate question means accurate student, right? The acceleration due to the change in magnitude of the velocity in a circular track. Acceleration due to what? Due to the change. Look here, change in the magnitude of velocity. Change in magnitude of on a circular track is called gap acceleration. It's called, fill the gap for me. It's called tangential acceleration or centripetal acceleration because it says acceleration due to the change in magnitude. That's why centripetal it can't be. So the answer is tangential acceleration. Question number 5, the acceleration due to the change in direction. Look here. Change in the direction of velocity in a circular track is called space acceleration. Which type of acceleration? Is it tangential or centripetal? I'm sure you know the answer. Let's say, and before me, you guessed the, let's say, you could guess the right answer, which is centripetal acceleration, because I told you it's the only type of acceleration that is created by means of changing direction of velocity. Question number 6, which of the following conditions, right, are more likely happen for an object moving in a circular track with constant speed? Look here. Constant speed means Vt is constant. Means Vi and Vf is equal to 0. If Vt is constant, what does it mean? It means Vi, initial velocity, and final velocity is equal to 0. Means the object moves with a constant rate. The object doesn't, let's say, neither speeds up nor slows down. It moves on a, let's say, on a constant rate, right? So, which condition is available or which condition is satisfied in the case of constant speed? When Vi and Vf is equal to 0, At is equal to 0, right? AC is equal to 0. Does it make sense to you? I told you, let's say AC never becomes 0, right? AC never be 0 at all. What do you say about A and B are correct? It's not actually. Say C, it's not correct. Till now, let's say we accept this one. We accept this option till now. D, it says AT and AC exist. So in which situation AT and AC exist together simultaneously? Only in one situation AT and AC, let's say, are present simultaneously when the object moves around the circular track with the varied velocity, with a variable velocity. When the object speeds up, right, along a circular track, or when the object slows down around a circular track, no problem. In this situation, AT and AC exist simultaneously. But here, let's say, it mentions the condition. Question mentions the condition. It's that constant speed. So the object neither speeds up nor slows down. That's why only one type of acceleration becomes 0, AT becomes 0. I told you AC never be 0. So this one is true. Question number 7. Give an example of a situation in which an automobile driver can have a centripetal acceleration, means AC exists, right? But no tangential acceleration. But AT is equal to 0, right? Think about this situation when an automobile, let's say car driver, has what? Has a centripetal acceleration. What does it mean? It moves, when the car moves along a circular track, AC exists automatically, right? But no tangential acceleration. In which situation AT becomes 0? When the tangential velocity is constant, right? When Vt becomes constant. A car moving on a straight path, so it's wrong from the beginning because it says a car moving on a straight path. On a straight path, AC does not exist actually. AC is dedicated only for a circular track. So that's why we ignored A. A is not true. B, a car driving in a circle at a constant speed. Nice, right? Car driving in a circle. So the first part, it mentions circular track. That's why AC automatically is created at a constant speed, and the speed does not change. The object neither speeds up nor slows down. That's why this option till now is true. C, a car driving in a circle with changing tangential speed. It's wrong. The first part, we accept the first part, no problem. A car driving in a circle, no problem. AC exists. It's nice. But it says with changing tangential speed. When the tangential speed changes, actually AT does not become zero, right? So it says no tangential acceleration. In this situation, AT and AC exist simultaneously, and we don't need this, let's say, this situation. D, none of the above. So the only, let's say, the only thing that is true, the only option that is true is B, a car driving in a circle at a constant speed. Constant speed means no tangential acceleration, means AT is equal to zero, but AC still exists. Let's move on to another question, which is question number, and by the way, this question I let's say read it for you. It's a question of national exam, and the next question is the question of national exam as well. Let me read it for you. Question number 8. The acceleration produced because of the change in velocity's direction in a circular track. The acceleration produced because of the change in velocity's direction. Change in velocity's direction. Acceleration, I told you, the only acceleration due to the change in direction of velocity is centripetal acceleration or tangential acceleration or angular acceleration. Guess one of these. Of course, you are correct. Only centripetal acceleration is due to the change in, let's say, direction of velocity. Angular speed, it can't be. It's wrong. Angular acceleration, it's wrong. Tangential acceleration is wrong. Only centripetal acceleration. So, and this is the question of national exam. Thank you very much, guys, for watching this video. I want you to follow our next videos, and see you later.